The rope in your garage frays stiffens and snaps before the year is out. Meanwhile, medieval ropes hauled ships, lifted cathedral stones and held drawbridges for decades without quitting. This wasn't luck. It was skill, patience, and a deep understanding of materials that modern mass production quietly abandoned. Today, on Ancient Roots Uncovered, we're pulling on that thread to reveal why medieval rope lasted longer than yours ever will. Natural fibres built for endurance. Medieval rope makers didn't just grab any plant and twist. They selected fibres with brutal honesty. Hemp dominated because its long cellulose chains create high tensile strength and natural resistance to rot. Flax followed closely, especially in northern regions where climate helped produce strong stems. In some coastal zones, craftsmen used bast fibres from lime trees or even horsehair for specialised cords. The key difference wasn't just the plant, it was the maturity of the plant. Fibres harvested too early weaken fast. Too late, and they turn brittle. Medieval growers timed harvest windows with obsessive precision, sometimes guided by seasonal cycles passed down through guild knowledge. That meant the rope started its life already stronger than most modern hardware store rope. Modern rope often uses mixed fibres, short strands, or synthetic blends optimized for cheap production rather than longevity. Strong at first, sure. Durable for decades, not really. Slow processing made fibres tougher. Before twisting ever began, medieval fibres went through retting, drying, beating and combing. Retting essentially controlled rotting, loosened the fibres without breaking them. Too short a soak, and the fibres stayed rigid. Too long, and they weakened. Skilled workers judged readiness by smell, colour and feel, not timers. Once dried, fibres were hackled with iron combs to align them into long, parallel strands. This alignment matters. Rope strength increases dramatically when fibres run straight rather than tangled. Medieval rope makers understood this intuitively. Modern machinery often shreds fibres shorter to speed production, sacrificing that long strand advantage. The result back then was rope with consistent load distribution. Instead of one weak point snapping under stress, tension spread evenly along the length. That's why medieval ropes failed gradually rather than catastrophically. Twisting was a science, not a shortcut. Medieval ropewalks could stretch hundreds of meters. Workers twisted fibres slowly, controlling tension by hand or with weighted spindles. Each strand was twisted in one direction, then combined in the opposite direction. This counter-twist locked fibres together and prevented unravelling. This wasn't random technique. The physics behind it is solid. Counter-twisting increases friction between fibres and distributes stress. Even today, the strongest cables follow the same principle. Modern ropes are often machine-twisted at high speed. Fast production introduces uneven tension. That creates micro-gaps between fibres, and those gaps invite moisture, dirt, and internal wear. Medieval rope makers would have considered that sloppy work. Oils and tars turned rope into armour. A huge secret to medieval rope longevity was treatment. Ropes were soaked in oils, animal fats, pine tar, or wax mixtures. On ships, tarred rope resisted water, fungus and salt. On land, oil-treated rope stayed flexible and resisted cracking. This protective layer slowed oxidation and blocked microbial decay. Essentially, the rope gained a primitive but effective waterproof coating. Some surviving historical ropes show that tar penetration reached deep into the fibre core, not just the surface. Modern ropes sometimes get chemical coatings, but many cheaper ones are untreated. They look fine on the shelf, yet degrade rapidly outdoors. Medieval rope makers expected ropes to face harsh weather. They armoured them accordingly. Rope makers were elite specialists. In medieval Europe, rope making wasn't casual labour. It was often guild-controlled knowledge. In trading networks like the Hanseatic League, reliable rope was vital for ships, cargo and harbour cranes. A failed rope meant lost goods or dead sailors. That made rope makers critical infrastructure. Apprentices trained for years. They learned fibre grading, moisture control, twist ratios and maintenance methods. Rope wasn't just manufactured, it was engineered. Compare that to modern consumer rope produced in factories optimised for volume. Today's rope is built to meet minimum safety standards, not to last a generation. Maintenance kept rope alive for decades. Medieval ropes didn't survive because they were immortal. They survived because people maintained them. Ropes were regularly dried, retarred and inspected. Damaged sections were cut out and respliced. A well-maintained rope could serve for years because its weak spots were managed early. Records from shipyards in regions influenced by the Roman Empire and later medieval ports show ropes being logged, treated and stored with almost ritual discipline. Rope was expensive. Replacement was slow. Care was cheaper. Modern rope gets tossed in a shed, left in the sun, soaked in rain and forgotten until it snaps. The medieval mindset treated rope as infrastructure. We treat it as disposable. Design matched purpose perfectly. Medieval rope makers tailored rope to specific tasks. Thick hemp hawsers for ships, fine flax cords for pulleys, hair ropes for special tension work. They adjusted twist density and strand count based on expected load and environment. This level of customization meant each rope was built for its job, not a one-size-fits-all product. Even innovators like Leonardo da Vinci studied rope tension and pulley mechanics, illustrating how critical rope technology was to engineering progress. When the smartest minds of the era cared about rope physics, you know it mattered. What this means today. If you want rope that lasts, medieval lessons still apply. Choose natural long fibre materials when possible. Keep rope clean and dry. Treat it with oils or protective coatings. Store it out of sunlight. Inspect and rework weak sections early. The truth is, the medieval world didn't have better materials. They had better habits. Patience over speed. Craft over convenience, knowledge over shortcuts. And that mindset turned simple plant fibres into lifelines that held kingdoms together. If you enjoyed uncovering this forgotten craft, make sure you subscribe to Ancient Roots Uncovered and share this video with someone who still thinks the past was primitive. History isn't just stories, it's solutions waiting to be rediscovered.